Let's now take a look at estimating various quantities. So this is a very important skill in mathematics and problem solving because sometimes you just want to see whether or not an answer to a problem is reasonable. And so often we can just look at an estimate or an approximation for a particular quantity. Now remember, with estimating, we're just looking for an approximation. We're not worried about it being an exact answer. So this would be a kind of number that you could do in your head, not something that you would have to have a calculator for. We can also take a look at a picture and try to estimate. You've probably encountered one of those contests where you try to estimate how many jelly beans are in the jar or something like that. Well, how would you do an estimate of something like this? Well, one strategy that you might use is to divide this into smaller sections, count those sections, and then multiply by how many sections that there would be. So here, if we make a 3x5 grid, and then within one of those grids, we could count the blueberries. Since there are 15 grids, whatever we got as our answer for the one square in our grid, we would multiply by 15 to get our estimate. Now, it's not going to be exact, but it's going to be close enough for us to have a good idea at what the quantity is. So if you take any of these squares, you'll probably get a number close to 13. Take that 13, multiply by 15 for the squares, and so we could say that there's approximately 195 blueberries in this photo. Another thing that we need to look at for this course is what's called scientific notation. Now, scientific notation may not feel like it's an estimate, but what it's going to do is it is going to provide us with some strategies that can help us when we're estimating really big or really small numbers. So as a quick review of the powers of 10, whenever you are multiplying by a positive integer power of 10, what that means is you are moving your decimal point to the right. So 8.44 times 10 to the 7. Well, 10 to the 7 is the same thing as 10 million. But you could get that without thinking about the 10 million by moving your decimal 7 places to the right. You'll need to add in some zeros so that you have room to move to the right, but 8.44 times 10 to the 7 is the same thing as 84,400,000. Now, when you have a multiplication by a negative integer power of 10, you're going to be moving the decimal point to the left. So 8.44 times 10 to the negative 7, well, that's like division. But what you can do to simplify that calculation is just move your decimal place 7 places to the left, adding in the zeros that you need so that you can actually continue to move the decimal. So for scientific notation, what this is a number that's expressed as the product of two factors. The first one's going to be a number that has to be between 1 and 10. Now you can't have 10, you can have up to 10, but not including 10. And then the other is going to be an integer power of 10. So for example, 2 times 10 to the 30 kilograms, that's the mass of the sun. That's a huge number. Written in scientific notation, it's a lot more manageable to look at. Would you like to see 2 with 30 zeros afterwards? Probably not. So scientific notation gives us a simpler way to write a really big number. 9 times 10 to the negative 31 kilograms, that's the mass of an electron. And if you've taken a science class, you know that an electron is teeny tiny. And so this would be 30 zeros after the decimal and then the 9. That's a very, very small number. So scientific notation allows us to write this really small number in an easier way. So for example, to write in scientific notation the weight of 31 million orchid seeds, that's only 1 ounce of weight. So orchid seeds are very, very tiny. If we wanted to write that in scientific notation, then what we would do is we would move our decimal so that it is between the 3 and the 1, because you're looking for your number to be, the first number to be between 1 and 10. So I want my decimal place to be between the 3 and the 1. So how many times did I have to move my decimal to the left? Now notice this is backwards of the rule because we're not in scientific notation. We're trying to write into scientific notation. So you move to the left 7 places. And so our scientific notation would be 3.1 times 10 to the 7. You can check that by moving backwards using the rule for scientific notation. Now we have a sea virus called a femtoplankton, and it's approximately 0.000000018 of a meter. If we wanted to write this in scientific notation so that it didn't have so many zeros, we would see that we had to move to the decimal 1, 2, 3, 4, 5, 6, 7, 8 places to the right. This is going to give us a negative exponent, and so we have 1.8 times 10 to the negative 8. With the scientific notation, one thing that you can remember is that if you have a number that's bigger than 1, the exponent's going to be positive. And if you have a decimal number that's smaller than 1, so it's 0 point something, you're always going to have the exponent with a negative power.